Welcome back. What I want to do with you in this short video is to combine all three of the gas laws we have visited. We've looked at Boyle's law, pressure and volume. We've looked at Charles' law, volume and temperature, and we've most recently looked at Gay-Lussac's law, which involves pressures and temperatures. Now we're going to bring all three together and come up with a very useful gas law, which is known as the combined gas law. So let's take a look. Well, we know that the volume and the pressure and the temperature of a gas can all vary at the same time. The imploding can trick demo that I've done for you demonstrates that. Clearly, the temperature of the water vapor in that can went up. Its volume went down though as the pressure dropped when we inverted it into that container of ice cold water. Beautiful example of the real world, which shows that all three variables can change. We have our equations in front of us. Boyle's law, P1V1 equals P2V2. Charles' law, V1 over T1 equals V2 over T2. Gay-Lussac's law, P1 over T1 equals P2 over T2. Well, you can see that volume and pressure are both in the numerator or on the top. Temperature happens to be on the bottom. So if we bring these together, it kind of makes sense that we're going to have P1V1 and P2V2 on the top and T1 and T2 on the bottom. And this, my friends, is known as the combined gas law. The beautiful thing is if you forget one of the other three, they're all built in. Because if I cover up temperature, you can see we have Boyle's law. And if I cover up volume, we have Gay-Lussac's law. And of course, if I cover up pressure, you can see we have Charles' law. So P1 V1 over T1 equals P2 V2 over T2. We have to be able to rearrange for certain variables. So I want to take a little bit of time here and solve for P2, V2, and T2 using our combined gas law. Well, if we look at our combined gas law, P1 V1 over T1 equals P2 V2 over T2, P2 is here. So instead of moving P2 to the bottom on the left side, let's leave it here, and you can see that P1 V1 over T1 still remains in place on the left side of the equation. If I want to solve for P2, then I've got to multiply both sides by T2 and divide both sides by V2 in a sense. So what we get is that the T2 on the bottom on the right ends up going to the top on the left. And the V2 on the top on the right goes to the bottom on the left like this. So that's as easy as it is. P2 is P1 V1 over T1 times T2 over V2. Let's look at V2. It's very similar to P2 because it's also in the numerator. Likewise, if you think about it, P1 V1 over T1 is all sitting here on the left side, and now we're going to solve for V2. So in this case, we have to divide both sides by P2, and we have to multiply both sides by T2 to isolate for V2. So in this case, the T2 is going to be on the top, and the P2 is on the bottom. And that will give us V2. So that makes sense. Now, one might argue that finding a temperature is the hardest of the three. The reason for that is that it is in the denominator. It's on the bottom. And there are many ways to do this, but what I recommend is to cross multiply. It's always better to get your unknown variable in the numerator or on the top as opposed to being on the bottom. So we're going to move T2, in this case, from the bottom on the right side to the top on the left side. And what I'm going to do is rewrite this entire equation out again so that we can see what's going on. So here it is. There. That is our original equation. We want to solve for T2. This is our unknown. So we want to move it to the top on this side, and this is going to have to go down if we divide both sides by P1, V1. On the other hand, T1 has to go up. We have to multiply both sides of the equation by T1 to clear that out of the way. And if we solve this way, T2 ends up being alone on the left side. The P2 and V2 are already there, so we don't have to worry about them. T1 is on the bottom on the left, so it's going to join the P2 and V2 on the top. And the P1 and the V1 go down below like this. And that is really cross multiplication. If you want to go through and show your work and divide both sides and multiply both sides like you would in math, that's fine. But just think about what's really going on here and you should be good to go. There's no adding or subtracting here, so we can take things back and forth and follow the arrows. T2 is P2V2 times T1 over P1V1. That is a combined gas law equation. And now, after this, our next step is to put it to work in a real life example.